All right, so this is the first problem on the guided notes. All right, so it says Justin is a Justin is a wedding coordinator, and she is selecting the menu options for the reception. All right. First, you will give the guests a choice of salad or soup for the first course. Then she will give them a choice of chicken, steak, or vegetarian. And then finally, she will allow guests to either choose vanilla cake or chocolate cake. And the question is, how many different plausible, possible, different meals you could have? Like totally different. All right. So what they do is they tell you to do a tree diagram. So let's do a tree diagram. There we go. So the first choice is soup or salad. So we'll call soup SP and salad ST. Okay, here we go. All right. So if you pick soup, what are your next choices then for your second meal? Remember? What was it? You got it right there. Chicken, steak, chicken, steak, or vegetable, right? So somebody could pick a soup, pick chicken. That's going to be different. Somebody picks soup and steak, right? And that's going to be different. Somebody picks soup and a vegetable plate. Or they could pick a salad and pick salad and chicken, or salad and steak, or salad and a vegetable dish. All just the first two courses, everybody's different here, right? So now we add the cake at the end then, right? So if somebody picked a soup and chicken, now they got to pick between what? Vanilla and chocolate. But this person's got to pick between vanilla and chocolate cake. This person's got to pick between vanilla and chocolate cake. The same here. Vanilla, chocolate cake. Vanilla, chocolate cake. Why am I doing chocolate cake? Chocolate CH. And then the last one, vanilla or chocolate cake. VA, chocolate cake. Okay. So how many total different ones do we have? We have soup, chicken, and vanilla. Soup, steak. I'm sorry, soup, chicken, and vanilla. Soup, chicken, and chocolate. Soup, steak, and vanilla. Soup, steak, and chocolate. Soup, vegetarian, and vanilla. Soup, vegetarian, chocolate. You follow how every single one's different, right? So they ask if you're asked to do a tree diagram, that's what it is. But then let's just go ahead and look at this like this. All right, where's my eraser? Under the binder thing. Where is it? Here. Okay. So now the bottom line is that's too hard to do to go on like that. That's I don't care if you wrote it down or not. The tree diagram. If you did, fine. All right. Just don't tell my other teacher. Okay. So now, so check this out. Let's say I did this right here. All right. And this I called it A and B. And this I called A, B, and C. All right. So there's 2 letters here and 3 letters here. And I say, how many different combinations of letters can you have? If this letter's got to be first and those letters second. So this would be AA. Everybody see it? A and A. All right. This will be what? A and B. A and C. They're all different, right? This one's going to be B and A. B and B. And B and C. So only 2 letters, but there's 6 different possibilities, right? Because it's just counting all the possibilities. So what it is this is what they use in this fundamental counting principle, which is this. So if you had 2 choices and 3 choices, there's a total of 6. So let's go back to this problem again. So how many choices was it for the super salad was 2, and then steak, chicken, or vegetable was 3, and then chocolate or vanilla was 2. 2 times 3 is 6, and 6 times 2 is 12. That was the answer, right? So you don't got to do this tree diagram to figure it out. So what we're going to do now in a minute, we're going to look at some more difficult problems where the numbers are much bigger, and then you use this process. Okay.